Welcome to chemistry classes. In this video, we are going to discuss about percentage yield and percentage purity. Last part of stoichiometry, we have to discuss here percentage yield and percentage purity. Okay, so here first we have to discuss here percentage yield. Yield means amount of substance formed by a chemical reaction. Amount of substance or amount of product formed during a chemical reaction, that is yield. Okay, to find percentage yield, actual yield divided by theoretical yield times 100. This is the equation to find percentage yield. Percentage yield means actual yield divided by theoretical yield, or you can say calculated mass. Actual mass divided by calculated mass times 100. Actual mass means mass given in the question. Okay, I will give you here example. Actual mass means mass of the substance formed during chemical reaction. It will be in the question. Okay. And here calculated mass means we know number of moles is equal to mass divided by molecular mass. We know number of moles is equal to mass divided by molecular mass. By rearranging this equation, we can find mass of the substance equal to number of moles times molecular mass. So we can find mass using this equation. This is calculated mass. Actual mass means mass given in the question. Okay, so based on this is equation to find percentage yield. Actual mass divided by calculated mass times 100. Okay, so based on this we have one question to find percentage yield. Okay, so see here, aspirin, it is one medicinal drug. Aspirin, it is one drug. It used as painkiller. Okay, aspirin made from salicylic acid. Aspirin producing from salicylic acid. Okay, aspirin, its molecular formula C9H8O4. This is aspirin. This aspirin made from salicylic acid. Salicylic acid, its molecular formula C7H6O3. Okay, also it is given in the question 1 mole salicylic acid gives 1 mole aspirin. It is given in the question 1 mole salicylic acid gives 1 mole aspirin. So salicylic acid aspirin mole ratio 1:1. 1 mole salicylic acid gives 1 mole aspirin. Clear? So based on this, see here, 100 gram salicylic acid gives 121.2 gram aspirin. Okay, this is question. 100 gram salicylic acid gives 121.2 gram aspirin. So find percentage yield. So this is the question. Asking here 100 gram salicylic acid gives 121.2 gram aspirin. So find percentage yield. So how can you find percentage yield? This is the equation to find percentage yield. Actual mass divided by calculated mass times 100. So what is actual mass? Actual mass means the mass obtained by experiment. It is given here. 100 gram salicylic acid gives 121.2 gram aspirin. So the mass of aspirin formed during chemical reaction, it is given here 121.2. This is actual mass 121.2. Okay. Now we have to find here calculated mass. Clear? So see here, to find calculated mass, this is the equation. Mass is equal to number of moles times molecular mass. Clear? So here it is given in the question molecular mass of salicylic acid. Molecular mass relative molecular mass of salicylic acid 138. It is given in the question. You can see the question. Okay, molecular mass of salicylic acid 138. Similarly, relative molecular mass of aspirin also given in the question. It is 180. Okay, relative molecular mass of aspirin 180, relative molecular mass of salicylic acid 138. It is given. Okay, so here I told you here to find percentage yield, actual mass divided by calculated mass times 100. Actual mass given in the question, it is 121.2 gram. So we have to find here calculated mass. To find calculated mass, number of moles times molecular mass. So you need molecular mass of aspirin. Okay, we have to find percentage yield of aspirin. Aspirin is the product. We have to find its percentage yield. Okay, so we have to find number of moles of aspirin. Okay, so it is given in the question, 1 mole salicylic acid gives 1 mole aspirin. 1 mole salicylic acid gives 1 mole aspirin. So here 100 gram salicylic acid gives 121.2 gram 100 gram salicylic acid 121.2 gram aspirin. Okay, so using this we can find number of moles of salicylic acid. Number of moles of salicylic acid, mass divided by molecular mass. Salicylic acid mass is given 100 and its relative molecular mass is given in the question 138. So number of moles of salicylic acid 100 divided by 138, its answer 0.725. So number of moles of salicylic acid 0.725. 0.725 moles. Look here. Salicylic acid and aspirin mole ratio 1:1. 1 mole salicylic acid gives 1 mole aspirin. The ratio 1:1. In this chemical reaction, what is the number of moles of salicylic acid? Number of moles of salicylic acid 0.725. So look here once again. 1 mole salicylic acid gives 1 mole aspirin. So 0.725 moles, 0.725 salicylic acid gives 0.725 aspirin. You understand? Salicylic acid, aspirin 1:1 ratio. Salicylic acid number of moles here 0.725. So here this is unknown value. So you can do cross multiplication. Okay. So also you will get y equal to 0.725. Or you can understand like this. 1 mole salicylic acid gives 1 mole aspirin. So you can say 0.725 moles of salicylic acid gives 0.725 moles of aspirin. So here you got number of moles of aspirin 0.725. Number of moles of aspirin 0.725. Now why we do this calculation? We need this one, calculated mass. How can you find calculated mass? Calculated mass is equal to number of moles times molecular mass. What is number of moles? Number of moles here, number of moles of aspirin we calculated now 0.725. 0.725. And what is the molecular mass of aspirin? Molecular mass of aspirin given in the question, it is 180. 180. Okay. So molecular mass of aspirin 180. When you multiply this, you will get its answer 130.5. When you multiply 0.725 times 180, your answer will be 130.5. Okay, so 130.5, that is calculated mass of aspirin. Now you have all data here. Actual mass given in the question 121.2 divided by 130.5 times 100. That's we did here 121.2 divided by 130.5 times 100. So your final answer will be 92.3. So your final answer is 92.3. So here we discuss percentage yield. So here you have to remember how to find percentage yield. Percentage yield, actual mass divided by calculated mass times 100. This actual mass always given in the question. Okay. Actual mass means mass of product formed during chemical reaction. Okay, calculated mass means we have to find this number of moles times molecular mass. Okay, these are the different steps to find number of moles. We already discussed how to find number of moles. Also, you can check the past paper, you can check the playlist, and you can see many past paper how to find number of moles during in different years past paper. Okay, next one we have to discuss here percentage purity. Next one we have to discuss here percentage purity. To find percentage purity, we have mass of pure substance divided by mass of impure substance times 100. We have one chemical reaction. Okay, during chemical reaction we obtained a product. Okay, this product with some impurity. There is product, we need required product, also there is some impurity. So we want to find the percentage purity. So the mass of pure substance divided by total mass of the product or mass of impure product times 100. Okay, this is the equation. Based on this, we have one question here. Salicylic acid, we discussed before aspirin and salicylic acid. Okay, salicylic acid produce aspirin. Okay, so we have some sample of aspirin. Okay, and we want to find its percentage purity. We prepared aspirin using some method, and we have aspirin, and we want to find its percentage purity. So look here, to find percentage purity, the given aspirin reacting with sodium hydroxide. Aspirin, it is acidic and it will neutralize it will react with the base. It will react with sodium hydroxide. Aspirin react with the sodium hydroxide and it produce salt and water. Okay, so using this equation, it is given in the question. You can see here, look here, 1 mole aspirin reacting with 1 mole sodium hydroxide. Okay, so we discussed before 1 mole salicylic acid gives 1 mole aspirin. Similarly here aspirin and sodium hydroxide, their ratio is 1:1. 1:1 ratio. 1 mole aspirin reacting with 1 mole sodium hydroxide. Clear? So look here, we selected 4 gram aspirin. 4 gram aspirin reacting with 17.5 centimeter cube of 1 molar sodium hydroxide. Okay, so find percentage purity of this aspirin. This is the question here. 4 gram aspirin reacting with 17.5 centimeter cube. 17.5. This is the volume of sodium hydroxide, 17.5 centimeter cube. And this is the concentration of sodium hydroxide, 1 molar, or you can say 1 mole per decimeter cube. Okay, so this is concentration and this is the volume of sodium hydroxide that reacted with 4 gram aspirin. So we want to find percentage purity of this aspirin. Okay, also here in the question it is given molecular formula of aspirin C9H8O4. Okay, using this you know relative atomic mass of carbon 12, hydrogen 1, oxygen 16. So you can find molecular mass 180. Molecular mass of aspirin 180. Okay, so here to find percentage purity, we want to find percentage purity. This is the equation: mass of pure substance, mass of pure aspirin divided by mass of impure product times 100. Okay, so to find percentage purity, we need here mass of pure substance and mass of impure substance. Mass of impure substance already given here. Mass of impure product or impure substance already given here 4 gram. Okay, so here 4 gram aspirin mean aspirin. There is aspirin and some impurity. So we need to find the mass of pure aspirin we have to find. Okay, so here aspirin with the impurity, it will reacting with the sodium hydroxide. So when you react given sample with the sodium hydroxide, only aspirin reacting with the sodium hydroxide, impurities do not react. Okay, so here using mole ratio we can find mass of pure product, mass of aspirin present in the given sample we can find using this mole ratio. Okay, so this is the equation. Using this equation you can see here 1 mole aspirin reacting with 1 mole sodium hydroxide. Aspirin and sodium hydroxide, their mole ratio 1:1. Okay, we can find number of moles of sodium hydroxide using this equation. We know we are given here sodium hydroxide, its volume 17.5 centimeter cube and concentration 1 molar. Okay, so how to find number of moles of sodium hydroxide? Number of moles of sodium hydroxide, CV. Okay, here volume it is given centimeter cube. To convert decimeter cube we use CV over 1000. Okay, concentration 1, volume 17.5 divided by 1000. So here answer number of moles of sodium hydroxide 0.0175. So look here, aspirin and sodium hydroxide mole ratio 1:1. We know number of moles of, we calculated number of moles of sodium hydroxide 0.0175. So when you cross multiply this, you can find, look here, you can find number of moles of aspirin. This is unknown value. You can calculate this unknown value like this. Look here, y equal to y times 1 equal to 1 times 0.0175. So this unknown value will be 0.0175. So number of moles of aspirin here 0.0175. Clear? So you have number of moles of aspirin and you have relative molecular mass of aspirin. It is given here 180. Okay, so using this information you can find mass of pure product. Mass of pure aspirin is mass of pure aspirin, number of moles times molecular mass. Number of moles we calculated 0.0175 times molecular mass 180. So here mass of pure product 3.15. Mass of pure aspirin is 3.15. So how can you find percentage purity? Mass of pure product. Mass of pure product means 3.15 divided by mass of impure product. It is given here 4 gram. So 3.15 divided by 4 times 100. So here percentage purity here 78.75. 78.75. Okay, so this is the answer. Clear? So here remember, to find percentage purity we have to do here mass of pure product divided by mass of impure product times 100. Mass of impure product mean the given mass. Mass of pure product we will calculate. Mass of pure product we will calculate like this. Mass is equal to number of moles times molecular mass. Using this equation we will find mass of pure product. Clear? So here one more example to find percentage purity. So look here, chalk mean calcium carbonate. Chalk mean, pure chalk mean it is calcium carbonate. Okay, so here chalk reacted with excess dilute hydrochloric acid. Chalk reacting with excess dilute hydrochloric acid forms, okay, here chalk reacting with excess dilute hydrochloric acid, it produces carbon dioxide. Carbon dioxide gas is formed at room temperature and pressure. The volume of carbon dioxide formed 2280. This is the volume of carbon dioxide formed. Volume of carbon dioxide formed 2280 centimeter cube. Okay. So here we have to find percentage purity. 10 gram chalk reacted with excess dilute hydrochloric acid form 2280 centimeter cube of carbon dioxide at room temperature and pressure. So what is the percentage purity of this sample? Okay, we have to find the percentage purity of chalk. Clear? So here a balanced chemical reaction given here, calcium carbonate reacted with hydrochloric acid giving calcium chloride, carbon dioxide and water. So we have the information about calcium carbonate. Also we have the information about carbon dioxide. Okay, 10 gram calcium carbonate giving 2280 centimeter cube of carbon dioxide. So calcium carbonate and carbon dioxide. So look here, from the balanced chemical equation you can see here the coefficient of calcium carbonate 1. Coefficient of carbon dioxide and coefficient of calcium carbonate 1. So calcium carbonate carbon dioxide mole ratio 1:1. 1 mole calcium carbonate giving 1 mole carbon dioxide. Clear? So here we have carbon dioxide volume of carbon dioxide formed 2280 centimeter cube. Using this value we can find number of moles of carbon dioxide. Carbon dioxide, it is gaseous state at room temperature and pressure. We can find its number of moles using this equation, volume divided by 24. V over 24. We discussed already this. Okay. So here volume of carbon dioxide 2280 divided by 24. Volume here centimeter cube. So to convert decimeter cube we have to divide by 1000. Divided by 1000. Okay, to convert decimeter cube. So this answer will be 0.095. This answer you will get 0.095. Number of moles of carbon dioxide 0.095. Look here, we already discussed this calcium carbonate carbon dioxide mole ratio 1:1. Now we calculated number of moles of carbon dioxide 0.091. Cross multiplication, this is unknown value, calcium carbonate number of moles you have to find here. So number of moles of calcium carbonate will be here 1 times, okay, here 1 times unknown value will be equal to 1 times 0.095. So it will be 0.095. So number of moles of calcium carbonate also 0.095. Clear? So you have number of moles of calcium carbonate, it is 0.095. So here you have to find mass of pure calcium carbonate. How can you find mass of pure calcium carbonate? You can find mass of pure calcium carbonate, number of moles times molecular mass. Number of moles of calcium carbonate already we calculated 0.095. Now you need calcium carbonate, its relative molecular formula. Calcium carbonate, calcium it is 40, carbon it is 12, oxygen it is 16. Okay, so here 40 plus 12 plus 16 times 3. This answer will be 100. So relative molecular mass of calcium carbonate, it will be 100. Clear? Now here 0.095 times 100. Here number of moles, it is 0.095, relative molecular mass 100. So the mass of pure calcium carbonate, it will be 9.5 gram. Okay, so we have to find here purity, percentage purity. So what is the equation to find percentage purity? Mass of pure substance divided by mass of impure substance times 100. Mass of pure calcium carbonate 9.5 divided by mass of impure calcium carbonate, it is 10 gram. 9.5 divided by 10 times 100. So our answer, final answer will be 95 percentage. Okay, so remember, this is the equation to find percentage purity. Mass of pure substance divided by mass of impure substance times 100. Mass of impure substance always in the question. Okay, and the mass of pure substance we can find like this. Okay, number of moles times molecular mass. Number of moles we can find, number of moles of calcium carbonate we can find using mole ratio 1:1. We have the number of moles of carbon dioxide we can find like this. Then we can use mole ratio cross multiplication and we can find number of moles of calcium carbonate. Okay, and these are the things we have to discuss in this video. We have many questions related to this. We have many past paper questions related to this. Okay, you can check playlist and watch past paper questions related to stoichiometry. Okay, so thank you for watching this channel.